Yep. Fine. So we were discussing this question. Yeah.
So I'm Gopi. Can you repeat it? I didn't get this children thing. What you said.
Yeah. Yeah. One thing, Uma. I'll just take you a small example. Okay. So one thing is there, right?
I know this point that all the things letters should be at the leaf notes. That is one condition. So that we can find this answer. But you said something else. That's right.
Yeah. See, if it is like this, okay. Can you tell me, like, consider this graph, Uma,
Okay.
the smallest graph. Okay. Can you just tell me the numbers for this? It is one for A, right?
Yeah.
And then
Zero. Yeah.
0, 1 for B. Okay. Can you tell me for C?
For
C.
C. 000.
0, 0, 0 for C, right? So the thing is, so this is not a Huffman, right? Because you have a single child, right? It's not a complete tree.
Okay.
Okay, so instead, what he told is that, so you're just having extra zero. So instead, what you can try to do is you can delete this, you can remove this, and promote C one step up.
Yeah.
Now see, if you put C over here, so this is also valid Huffman code, right?
Yeah.
You get the point,
Yeah.
It's
and it's
more
a way
efficient.
extra bit wasted.
Yeah.
Yeah, we want to reduce. We want to minimize the um,
Encoding.
ABL, right? Average bit length.
Yeah.
Yeah.
Okay.
Again, be careful with the term you use, Gokul. The term is full tree because complete tree is different from full tree.
Okay. Okay.
Yeah, careful with that. That's all.
So if that is the case, then why don't you tell us what is a complete tree and what is a full tree?
Yeah. So a full tree is where um, the the children there are either two children or there are no children, right?
Right. So for example, Huffman.
Exactly. There are either two children for a node or yeah. This is a full
Full
tree,
tree.
but this is not a complete tree because a complete tree uh, is filled
Level is also
in all
full, right?
levels except the last level.
Acha, okay. This is not complete, huh? Repeat, what did you tell? What is complete
No, no.
tree?
Yeah, complete tree it has to like fill complete level by level, right?
Hmm?
The last one has to be from the left. So this is not complete because the left side, so the right side is left side is empty, right? You understand? Yeah, this is
Yeah,
complete.
yeah.
Yeah,
Oh, okay. Okay. So if
you
this
guys should
if
check it
this
out.
had been if this had been transported over here, right? So then it will be a complete.
No. Sorry. One thing. I think I'm confusing also. Sorry. So in full tree, can you add two more elements in the rightmost down below? Two more children. Yeah, two more children. See, this
Fine.
is possible in a full tree, but this is not possible in a complete tree
Why?
because the previous level had to be full before going to the next level,
Okay. Got it.
right? The
Yeah.
last level
Hmm?
can have elements, but the previous level had to be full for complete tree. For a
Okay.
full
Okay.
tree, that doesn't matter. It doesn't matter if the previous level was not completed or not.
Yeah, can it be like this? Is this a complete tree?
Yeah. This is a complete tree.
But this is not a full tree.
It's not a full tree. Yeah.
Okay. Yeah, Afnan, please ask your question.
Yeah, one question. So can you kind of explain what is basically the difference between a complete tree and a full tree? I'm not getting that.
That is what we are trying to explain. I'll just take a picture if you don't mind.
Yeah.
Stephen, how do you say that complete tree is not a full tree on what basis?
No. The definition is such that a full tree. The definition of a full tree is that each node has to at least 0 or 2.
Oh,
It
okay,
cannot
on
have
that
1.
basis.
That's the
Okay.
problem.
Ah,
But a
okay.
complete tree can have 1. Just that
Yeah.
the last level, the last level,
Left.
only at the last level it can have that way, right? The
That is
previous
correct.
level has to be full before that.
Hmm. Correct. Afnan?
So a full tree is also a complete tree. I mean, I think
Yeah.
you can
Not
say that.
necessarily, right?
No. I gave an example of a full tree not being a complete tree, right? Can you go back to your paint?
See here.
So you can see that that is a full tree, right? But the previous level is not full at all. Can you
So
see?
Yeah, that is okay. But when are we saying that it is not a full tree?
When one child, like you can see in the second example, there's only one child to a node, right? At that time, it's not a full tree because the definition is it either has a zero children or two children.
Okay, for every node.
Yeah, for every
Yeah.
node. Yeah.
Correct, correct. So then it is complete, and then when it is complete, just to kind of recap.
Yeah,
Fill level
complete
by
is
level.
if filled level by level. So only the last leaf nodes they can be in any way. Like
Yeah.
it has to be. Can you just check if it has to be filled left to right? I'm not sure of that part alone. Like in this
Completely, right?
example, also I can see
Yeah,
left to right.
yeah, yeah.
Complete
Completely
tree. Does it
level.
have to be filled from left to right?
Then I'll take some here.
Except possibly the last is completely filled. So the previous levels have to be all filled before going to the next level. And are far left as possible. Okay, it has to be filled from left to right.
Huh. Okay. So that's okay, I think. Guys, just make sure you remember this
Yeah,
notation.
Yeah.
making sense now. Yeah.
Yeah,
Okay, great. Thanks, Shivanai.
yeah,
Seriously.
yeah. Okay.
Okay.
Glad I
Okay.
could help.
Yeah, yeah. So similarly, like these two can also be done, right? You guys, and
Yeah.
anyone can do
We can
this.
move on. Yeah.
And you can even by looking at this, you can see like 101 is here, and again 101 is here. So 101 is a prefix of B, so it's not a Huffman code, right?
Yeah.
Okay. So we'll go to the next question. So and we have a coding question here. We have a thing here, right? So which of the wait a minute, what is this? Huh? Okay. So in the given graph, if we try to find the shortest path from node A to all other nodes using the Dijkstra's algorithm given below, in what order will the nodes be marked as true in the visitor dictionary? Okay. And we have the order. Okay. This was similar to what we saw yesterday, but still we'll try to see what is here. Okay. Yep. I have taken that. Let me also take the code. Yeah. My God. The question is like in what order will the nodes be marked as true? Okay. Let me also take the options just in case. And I sneezed. Nice. Okay. Who want to try this? Afnan, you just joined. Can you do this?
Okay, I may try.
Might be interesting. Yeah.
All
Guys,
right.
try.
So,
Mhm.
so this is Dijkstra's, no?
Yeah. Excuse me
All
for
right.
the. Uh,
Okay. So we are starting from A, no?
mhm.
So we are starting from A, and then we will see that among the options that we can travel to, right? It is B, C, D. So among those, we'll I think we're choosing the minimum one, right? Which is not visited yet. So of course, nothing is visited apart from A yet. So we'll go to B then. Is that right?
Uh, hey, Vinay, Steven, can you take this?
Yeah, I'm here. I'm here.
I'm sneezing a lot. That's why I take it. Ah.
Yeah, yeah, sure, sure. Yeah, bees. Yeah, that's right. You're going in the right direction.
All right. Okay. So then from B, we can see that we can visit F, E, and also F and E only, I think, because from B
Yeah.
there are only two adjacent things. So among F and E,
So
E is
when
the
do you
minimum.
mark A as visited? When do you mark A as visited? I just want to know.
That is the source, no? So at the very beginning, we are marking it as visited.
Awesome, awesome. Yeah.
Yeah. So then we
And
go when we go
mm-hmm.
to B. When we go to B, that is like the potential vertex that we're going to visit, right? Because of that next V list. So at this moment, we have B, C, D. Among B, C, D, we choose B because it has the smallest distance. We go there, and then when we visit B, we'll mark this one as true. I mean, visited of B as true also. So that will
Yeah.
become true. Okay. So then from B we will see where all we can go. So then from B we can go to F and E. Among F and E we have E which is minimum, so we'll travel to E.
Yeah.
But then I think I'm going wrong somewhere because of the fact that E is not there in the correct sequence in the options.
Yeah. Why is that? Because so see, A to C is 6, right? So within 6 units, you reach C. You only reach
Correct.
E 3 plus 5, which is 8 units, right? So you
Ah,
update E to 8, but you don't reach it before C. So you're visiting
correct,
C
correct.
before E.
So among this, A to B to E and A to C, among these two possible
Yeah,
options, we have A to C, which is minimum. So then we'll go that way, I think.
exactly.
All right. So then we'll visit C. Okay. Okay. So then
So
we'll
what you
mark.
should do, just you should. I think what Google is doing, right? That you should do as you keep increasing. So you should make the distance to reach B as 3, C as 6, D as 20, and then update E to. So in the end, you just go in the order of low, like small to big, right? That's all.
Just sorry to interrupt, Shrivnay.
Yeah.
Even I'm
Yeah.
not getting. After visiting B, we will look for B to E, which is minimum, right? But why we are going to A to C?
What algorithm is this?
The extra
Dijkstra.
Okay, so in Dijkstra's algorithm, it is just like your forest fire, right, Uma?
Pardon?
Forest fire.
gas
If you
pipeline higher. Yeah,
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 pipeline, gas pipeline, right? So it's like if you start firing here, right? So third minute you are visiting B, correct?
Yeah, yeah.
Okay. Next, at the 8th minute only, you are going to visit E, but at 6th minute itself, you are gonna visit C.
Okay.
Correct.
But
Okay.
on the code, we choose the minimum one, right? So how are we choosing between 8, 5, 6? Is that so? I'm not getting that point.
yeah.
In
We
the,
are choosing between. Uh, see, so when you go to line number 8 in the code, right? It's next D is equal to min of distance V for V in W list. What you do in the first round itself, you update distance of B to 3, you update distance of C to 6, you update distance of D to 20, right?
okay,
And then when you start exploring B because 3 is lesser than 6 and 20, right?
yeah,
Yeah. When you explore B, you add you update the distance to F as 3 plus 8, which is 11. Sorry, yeah, 11. Uh, B to E as sorry, distance to E as 8.
yeah.
Now 6. Now you have 8, 6, 11, and 20 to choose from.
Got it.
So which one will you choose?
Yeah, yeah. 6, obviously. Yeah, yeah. That,
Yeah, yeah,
that is the point.
exactly, exactly.
Yeah,
Yeah,
thanks, Vinay. Thanks.
sure, sure.
Okay.
Yeah,
So
fine.
now
You
we
want to
have
finish it?
chosen 6. Yeah, now we have chosen 6, right? So now we are going to explore 6, right?
Yeah. From C, no?
Yeah, correct. So from C, so now 6 plus 7. What is 6 plus 7? That's 13,
13.
right?
13. Yeah.
13 is bigger than 8. You don't need to change it.
Yeah. So we'll not update and we'll go to E also again.
Correct. So
Okay.
you're not gonna. Am I right, Shivana?
Yeah, yeah, perfect. Yeah.
Correct.
Because we will be choosing minimum of whatever we give,
11, 8,
whatever.
and 20. Yeah, you'll be choosing between 11, 8, and 20.
Correct. So now we are choosing 8. So A, B, C, and E, right?
So okay. So in Dijkstra's, it may happen that we may sometimes, go away from that following the path that are there in
Yeah,
the
yeah,
graph, because what is
yeah.
happening is from A we go to B, and
Mhm.
then we come back somehow and then go to C, which is not.
No, we are not coming back, right? Like it's
Yeah, yeah, I understand. I understand. I mean, just to kind of
okay.
give an analogy,
Yeah, yeah.
it seems as if we are coming back from B and then going to C. So this
Mhm.
is only possible, I think, in Dijkstra's, because in BFS, what is happening is we kind of keep exploring the adjacent one.
That's different. Yeah.
Yeah, that's different. Correct,
Mhm.
correct. Okay.
Okay. Now let's complete this question. Come on, go ahead.
Okay. So we are at E now.
Yes. We
From
start
E
exploring E.
E. E. So B, we have already kind of visited that. C, we have
Mhm.
visited that. So D is the only option that we can go to, right? So
Once again. No, no, no. B. Okay.
okay,
Yeah, yeah. That's right. That's right. Yeah, you're right. So and we need to update the weight, right?
because G is also there, I can see that, but that is 25, which is larger than 20. So we'll go to D row.
Wait a minute. No, no, no. You just need to update the
You will still update it,
right.
right?
We
Don't
have to
forget to
update it.
update it. So
Yeah,
now it's at infinity. It's saying that okay, I can't reach G yet, but
but
you're
you'll
looking
update.
something. Yeah, you'll update it. Yeah.
Okay.
All right.
So updating G, what will you update G as? It is 33. 8 plus
Yeah,
25.
25, 33. Okay.
Right. So similarly for D, see now 20 you have, but if you come through this way, you will reach it in much earlier way, right? 18 itself you'll reach it,
Correct.
right? So you're gonna
Correct.
update it of 18.
18. Correct. Correct.
Okay, so now you have 18, and this is already visited, so you don't need to worry about this. 18, and you have 11 here, and you have 13 here. So
33. So
that is
we'll go
D.
to
Sorry,
F. Yeah, 11.
correct. Now we go to F. So F
Correct.
is
Correct.
going to be the fifth one. Okay. Yeah. So now we come to F. So F you are what 11, right? Now you explore F, which is the
D.
11 plus 30. It is going to be like 43, and you don't sorry 41. You don't need to change it because you can come in a much
33 is
much faster.
already smaller. Yeah, we'll not update that. Okay.
Yeah, will not update it. So now what is all you left with? 18 and
Everything
33.
else is already visited, right? So 18 and 33 will go to 18 from 18.
Correct. We'll go to 18, right? So
Right.
and so which is going to be the sixth one. Okay.
D.
So now we
Correct.
are here at 18. Now we explore this. So E has already been explored, right? Or visited, we can say. And 18 is
Right.
there, and then we can say like for H we need to update it as 28,
28. Correct.
right?
We
So
have
that's all. The only one,
33.
huh?
So we have 33 still remaining, no? 33 and
Yeah,
28.
33 on the left and 28 on this part. Correct.
So 33 is larger than 28, so we'll go to H first.
20, no, 28. Correct. H first. So it is 7, and then this is going to be the 8. So what's the order? Uh, A,
A, B,
B,
C, E, F, D, H, G.
C, E, F, D, H, G. I think A, B, C, E, F, D,
Yeah,
H,
that is
G.
correct.
You're right.
Correct,
Okay.
correct.
Yeah.
So this is nothing but just normal Dijkstra's algorithm,
Mhm. Correct, correct.
right? So in our GRPA or something, you remember the one code where it was like in my case, in my term, it was there, right? Different one where you have all the weights coming as 30, 30, 30, everything.
So
The timing
at the
testing.
at the at that point only, like if it is 10, then at the 10th second or whatever, 10th time instant, we will be
Uh-huh.
we'll have visited all the uh, nodes, right?
Mm-hmm.
Because everything is same, no?
Yeah, yeah. So it's okay. It's okay now. Let's go ahead with the next question. And if we have some question like that, we go ahead. Is that okay for all, guys?
Yeah.
Hello?
Yes,
Yeah.
yes.
Hey, hi Anwar. Anwar?
Good.
Hi, hi. That's you. Okay. So next question. Who wanna do this? Deepak, are you comfortable with AVL tree? Deepak, Anwar? Anyone who is comfortable with AVL tree? No one? I got.
I just joined Google. I just need to pick up. Okay. So
Yeah, we are doing the previous term question paper, so
okay.
nothing to pick up. It's like, are you comfortable? Okay, okay, you can. While talking, you can give in your thoughts. Who is gonna do this? Shibin, come on, try this question.
I'm also not sure. Gokul.
Okay, okay, you're having a kid. Okay, fine, please. Okay, who else can try this? Nomit, you did the previous question. Did you do the previous question?
No, but
Okay, so you wanna try this?
I can try, but I'm not sure whether I'll be able to solve.
Ah, it's okay. You try.
Does everyone have an issue with like is AVL tree is hard to understand for everyone? Is that what I'm understanding?
No, no, no. They have done it very well. You just see once
Okay.
you finish this, they just
Sure.
not confident enough. That's all.
Okay, no problem.
Okay. So go ahead, Nomit. Just read the question.
Okay, which of the following are true about AVL trees? Assume that height of the empty tree is 0.
Okay. For empty tree, when a node is equal to 0, the height is going to be 0. Okay. Fine. Okay. So let's go from the first option. Okay. So what? Read this. Read this point.
Let S of h denote the minimum number of nodes in an AVL tree of height h. Then S of h is equal to S of h minus 1 plus S of h minus 2 minus 1, where S of 0 is equal to 0 and S of 1 is equal to 1.
Okay, what is the problem here?
I remember the formula. So
Exactly, you remember the formula. What is the formula?
it would be +1. I think.
Very good. Yeah, that's correct. It's +1. So here it was -1, right? So that's the wrong here. And that's the mistake here. Okay. So coming back to the point, does everyone like just to give you a short intro about AVL tree. So AVL tree is like like balanced tree, right? So how do I tell this? So I think you guys should remember this. So and we'll see what is the weight of the slope. Uma, do you remember the slope? Calculating the slope and all?
Yeah, first one is just 1, right? 1 minus 0.
Yeah, slope equal to left minus right. So you have 1 minus 0, which is going to be like 1, and this is going to be
-1.
0. This is going to be -1. This is going to be -1. You're right. Okay, so this is the AVL tree with 2 nodes, correct?
Yeah.
This is the minimum AVL tree with 4 nodes. Fine. So that's the thing. So if you want to find, you remember there was one question given that what is the height of the minimum number of nodes present in the AVL tree of height 12? Right? You remember we are doing such a thing. Okay. So coming back here, exactly. So for 0, the number of nodes is going to be 0, right? For 1, it is just a single node, correct? Mahi? Okay. For an AVL tree of height, okay, this is height and this is number of nodes, okay, number of vertices, you can say like that. Mahi, tell me for 2, how many vertices you need? Look at this.
It's 2.
Very good. So this is height 2. Okay, so this is the level 1, level 2. Okay, so for 3, how much you have? 1, 2, 3, and 4. Okay, so for the next one, so how will you get that?
It's by formula is
Yeah, it's by formula. What is the formula?
SH minus 2 plus HH for the height -1.
Yeah, 2 plus 4 plus 1, not -1.
Yeah, +1.
Okay, so it's going to be 7. Okay, the trick here is, the idea here is why it is +1 is basically, so let's say if I want to draw the AVL tree, so we can say that this is the AVL tree of height 2. Am I right?
Yeah.
Right? Okay, this is the AVL tree of height 3,
3.
correct? Okay, if I want to draw AVL tree of height 4, how will I draw it? Simple. First, you draw the left on the left, okay, and you draw the similar tree, right tree on the right. Okay, so just draw one more point and then add it. Simple. Now on the left hand side, you have this is what? H of 2, and this is H of 3, right? And this is going to be +1. Got it? Why why the formula comes like that? H of 2, H of -2, H of -1, and +1. Got it?
Yeah.
Hope that is clear. Any questions on this, guys? Yeah, Shibin. So sorry, Shibin left. Nomit, sorry, you were doing this.
No questions.
Hope you got how the formula came, right? Great. Okay. So what's the next option? Next, say.
So
Hmm?
in AVL tree, the absolute difference between height of the left subtree and the height of the right subtree of any node can't be more than 1. Yeah.
That's correct, right?
Yes.
So and they are saying the absolute difference. I think everyone is okay with this, right, guys?
Yeah.
Any doubts in this? No, I don't think there's a doubt. Fine. So what about third option?
Yeah. So it's a balanced tree. So a balanced tree would have log n height. So
Yeah.
searching would
Searching
be.
for an element is going to be easier. Fine. Go ahead.
If the height of an AVL tree is h, the maximum number of nodes will be 2 to the power h minus 1.
So how do we arrive at this formula? Mhm.
Oh,
See, you start with here.
So may I
Okay,
add something here?
please. Yeah.
So my interpretation here is that since we have h levels, right, and in
Mhm.
each of those h levels we have two nodes, right?
Hmm. You're right.
Right. I mean, for every node that you have, you
Yeah.
get
So this is saying this talking about the maximum number of nodes, right?
yeah,
Maximum is going to be completely filled.
yeah. It is kind of filled. So at each level, at each level that we are going down, the number of
Mhm.
nodes is kind of doubling, right? So in the
Correct.
first one you have two, the other one you have four, eight, like that.
Mhm.
Right. So that is why we have 2 to the power h, and that minus 1 I think is because of the fact that at the topmost we have uh,
Only one,
only one. Yeah. Right. Right.
right?
So that was the idea.
Yeah. So this is height 1, 2. This is height 3. This is height 4, right? So and then 2 per 4. I mean, what is it? Is it height 1, 2, 3, or am I going wrong?
I guess the height at the first level is 0. So they
No. Remember that if you have
So,
one node, it's one
yeah,
height, right? So
yeah. Height is correct, but if you
the height is
calculate,
correct.
Okay. So the number of nodes, how is this done?
Yeah. 2 power h, 2 power 4 minus 1, right?
Okay, what is 2 per 4? 4, what is it? 8, 8 is a 16. 4 times 4. Okay, it's a 16. Okay, so I think I made a mistake over here. It's 2 per 3, right?
Yeah.
Here. On this level, it is 2 per 3. On this level, it is 2 per 2. Oh, okay, okay, I have put 2 only, and then here only I put 4 unknowingly.
Yeah. Yeah.
Yeah, yeah. So we have like 16 and minus 1. Okay, then this works fine. Is it clear for all, guys? Nomit, okay with this?
yeah. Just one question means if the tree is if all the levels are filled, so does this tree have a name? Means if
Perfect binary tree. You can search that up
Ah,
later.
exactly, perfect tree. While we were searching, also it came up saying that it was perfect. Okay, it's called as perfect tree. I'll come here. See this? Okay.
yeah,
And
yeah.
this is a balanced tree, AVL tree, like you have seen this, right? Balanced tree.
Hmm.
Got the point? Good.
Gokul,
Okay.
I
Yeah.
got confused at the last minute. How do you, I understood you written as a first level is one, height two. What is
Uh-huh.
the 2.0 is representing? That is little confusing.
2 per 0 is
Number
the
of
number of
elements
nodes.
in that level.
Hmm.
Okay, thank you. Yeah,
In that particular level.
okay.
Yeah.
Yeah. Excuse me. Yeah. All right. So we are coming to the last option. Go ahead.
The complexity of both insertion and deletion in an AVL tree
Mm-hmm.
is ON.
Is it so?
So see if it should be log n. I'm not sure.
Yeah. Consider that you're going to delete something over here. Okay. And there is this rearranging that is going to happen, right? Or let's
Mhm.
say that we are going to add something. Okay. So now that we are going to add something over here. Okay. So the AVL tree, I mean, how I tell you. Yeah, we need to check the balance, right? We just need to check the balance and then how long it is going to take. Maximum it is going to take like the rebalancing is going to take it till this point, right?
Hmm.
So it's going to be login.
Hmm. Clear.
Is it clear for all? Shrivana, am I right?
Sorry, I
Repeat it
didn't.
again. Say it again.
I told like insertion and deletion is going to take login.
Yeah, maximum login. O of login.
Correct.
Because it's a binary search tree. So I mean, binary search tree. You know that the height is. Uh,
Login, yeah.
yeah.
Hmm.
Yeah, actually, it's confusing between the heap and AVL, whether it is a binary search tree
Yeah.
or, yeah, it is like,
Yeah, yeah.
AVL is binary search tree. Just remember that. Yeah.
because the
Hmm.
height mainly differs, It's
Yes,
so
yes.
confusing. Yeah, thanks. Yeah.
Okay, great. So we'll go to the next question, shall we? Others, Mahi, are you okay with that?
Yes, sir.
Okay, nice. Thanks, too. Great. Okay. So now that Mahi told we'll go to the next question. Mahi will take this question. It is an easy question, right? This is the easiest question one can possibly get. And the answer is 6. Okay. Go ahead, Mahi. Read the question.
M1, M2 up to M11 are to be conducted in a single available meeting room. The table below gives the start and end times of these meetings. If any activity finishes at time t, then other activities can be started at time t or afterward. Okay, start and end time. What is the maximum number of meeting that can be held in the meeting room without conflicts?
Okay. This is
Okay.
more like scheduling, right? We have seen this similar.
So, okay, we can try.
Yeah.
For first, we have to do it like 4 to 7.
So if you remember, there were two strategies. I mean, there were two different scenarios, right?
Like interval scheduling and
this is interval scheduling and is minimizing lateness, right?
yeah.
Okay.
Yeah.
So interval scheduling, what did we do? We chose the one which has the earliest finishing time.
Okay.
What? Earliest finishing time. Okay. Okay. For minimizing the lateness, we chose the one again like shortest deadline. Okay. So if you have confusion, like I have recorded this. Okay, that's fine. According to this one, so we are trying to this is interval scheduling, right? So what is the idea? It's earliest finish time. Okay. So choose the one with the earliest finish time.
Gokul, sorry, minimizing lateness. What did you say? I didn't get it.
I mean, what was that? Earliest deadline or the shortest
Yeah,
deadline?
the
Okay,
same.
like,
Short. Yeah, earliest. Okay, same, right? Earliest finish time, earliest deadline is the same. Okay.
Oh, so sorry for that. Fine. I mean, there it comes as deadline, right? In this case,
Okay,
it's not.
okay. I understand. Deadline and finish time. Okay, okay.
Yeah. Mahi, where are we? Yeah. We choose the one with the earliest. Yeah, go ahead.
M2.
Yeah, we choose 2 first. All right. So it's going to start at second hour, right? And then end at third hour. Okay. Fine. Then
M8.
M2. So how do you choose? Okay. See, after doing this, what are you supposed to do? After you choose this, okay, this is the one with the shortest deadline. Okay. After you choose this, so you need to remove all the things which are conflicting with this time, right? Means at this time you have only one room, so which means M10 cannot run, right?
Yeah.
You can't have M10, so remove that. You don't want that anymore. I don't want that. Okay, so now 3 and 3 is fine. Finishing time and the starting time can be same. Okay, so what's the next one?
M8.
That's all. There is no other conflicting, so we go to M8. Okay,
And
so
we remove
M8
M1.
3 to 5. We are taking this. Go ahead. What did you say?
M1 also remove.
We should remove M1 because it has 4, right? Yeah, I removed it. That's all. Nothing else can be removed, right?
Yeah.
Okay.
Then M7.
Then M7 because it has the next minimum end time, right?
Yeah.
Good. Okay, we are choosing this M7.
And we remove M9.
Okay, we remove M9 because it's in between 6 and 8. Also, we should remove M6 also, right?
Yeah.
7 is in between. Yeah.
And then
No.
M5.
And then what? M5. So M5 it is 10 to 11. So which means like you should remove M4.
Yeah. And then M3.
Okay. Then you have M3.
And then M11.
Then M11. So how many do we have in between total? 1, 2,
3, 4,
3, 4,
5,
5.
6. 6.
And the answer is also 6. Hope anyone else, okay, Mahi, are you clear with this question?
Yeah.
Nice. So anyone else having any doubt on this question? Nikhil? Okay, Nikhil is not able to talk. Okay, Nomit? Anwar?
No, okay.
Yeah, Anwar, were you able to catch up? Deepak, Uma.
Yeah, I got it.
Okay, nice. So
I
we'll go
just
to the
want
next
to
question.
mention one thing, that earliest finishing time and deadline is not same, because deadline will be given a more time and the finishing time it could be within 3 hours, right? So that is little different only. In the
Okay. Yeah, that's what Q&A also accepted, right?
yeah, okay.
So it's
Minimizing
not the
effort.
same. Earliest finishing time and shortest deadline is not the same.
Yeah.
Hmm.
No. The thing is, yeah, you're always taking the same same deadline, but the next thing you're looking at is the what is starting earliest after that. That's all. Like I don't understand why you were making it like that. Yeah. One thing, if you're able to, so if you want to solve this question in the paper, I think it's better if you guys draw it on a sheet of paper. I think that's the best way to do it. So break it into chunks of 1 minute. Breaking like if for now you have 15 minutes, right? So break it into chunks of 1 to 15, and then add the jobs one by one. So it'll be easier for you to visualize and cancel out whatever
Yeah.
you can't have, right?
Yeah.
Yeah,
It's
that's
easier
right.
to do it that way. Yeah,
Yeah, even I was
overlapping ones
thinking
you
the
can
same
remove
thing.
easier. Yeah.
Works. Because you can't strike out like this in the
Yeah,
computer, right?
sometimes you might miss out, or like you might miss
Yeah.
the one that starts earliest. Yeah.
Mm-hmm. Fine. Okay. Going to the next question. Uh, this is also interesting. I think we have seen these also. Take this like this. Umar, do you remember the inversion, or who else want to do that?
Yeah.
Okay, you do this. Go ahead.
In an array A, two elements A of I and A of j form an inversion pair if A of I greater than A of j for I less than j. The maximum number of inversion pairs possible in an integer array A of size 12 is.
Hmm.
Do we have formula for that? Yeah,
We
it
have
is
done
n
this.
into 1 by 2. Is it correct?
N into n minus 1 by 2. Is that what you're saying?
Is it? I'm not very sure. Is it correct?
That's right.
Because
Okay. How do we come up with this?
in the worst case will be the maximum will be it is in the opposite like usually
Correct.
we remember like it should be in ascending order, but if it is in
Mm-hmm.
descending order it is the it
Maximum
that
number
will
of inversion.
get the maximum size, so that is actually n then
Yeah, yeah. Okay. Is it clear for all? Like for this, the formula is directly simple. N into n minus 1 by 2. Mahi, okay?
Yes, sir.
if the
All right.
number is given we have to calculate, right? If the order is given
Yeah,
instead
yeah.
of size it
That's
is
right.
given,
If
then
the
we
order
have
is given, we need to draw it, and then
yeah, we have
we match the pairs.
yeah.
Hmm. Fine. Okay. So yeah. So going to the next question. So what's this question? Consider the following class of tree nodes in a given tree. Answer the sub questions. Okay. So we have the node left, right, and the value. Fine. So traversal of the root. Fine. What is the order? See, which of the following order will be printed by the given code? Okay. Uma, who want to take this question? Anwar, can you take this question? This is just a code. I think we should be able to do this. No concept required. Anwar, are you here? Deepak? Deepak, can you talk? Deepak? No? Am I audible, Deepak? Okay. Afnan, would you like to try?
Yeah, so this is like
Easy
one
peasy.
of these in order, post order, or pre-order traversals, I believe. One of
Okay, I
those.
don't know. I don't know. So we have the left, right, and value. That's fine. Okay. So we come here. Like, shall we take it to the paint?
Yeah, sure.
So we can, So they're asking us what is the traversal that's going to happen, starting with the root node, and the root node is ideally 5, I think, right? What's the root node? Okay.
Yeah. 5 is the root.
So, okay. 5 is the root node. Okay. Yeah. Yeah. Okay. In this case, yes. Sorry for that. Yeah, Afnan, go ahead. We have
Right.
5.
So we'll start with 5. Okay. And then we'll call traversal of t dot left, right? So whatever is to the left of 5, which is 2 in this case, we'll call traversal for that.
Okay.
Okay. Then we will go into that recursive call, because for this function for 5 the call is getting suspended, right? Because we've
Correct.
gone into the another function call. So we'll
Yes.
just go to 2, and then from 2 we'll see we'll go to the left of 2 also. So then
Correct.
we'll get 1.
Mm-hmm.
Then we'll get 1.
Correct.
Once we get 1, we can see that there is nothing, to go to further from
So
there on.
actually we go to traversal of 1, right?
And
So
and
then
then we'll print 1.
we see left is nothing there, the right is
Hmm,
nothing,
hmm.
right? And then we print 1.
1. Correct. Then the
Okay.
previous suspended call will get resumed from
Mm-hmm.
2. So since we were at line number 3, traversal of t dot left, we'll go to
Mm-hmm.
line number 4 now, traversal of t dot right. So we'll go
Correct.
to 4. We'll go to 4, and then we'll go to traversal of t dot left. So we'll go to 3 again.
Correct.
And there we'll print 3 only, because there is nothing more to explore. We'll print 3.
Mm-hmm.
Okay. Then
Yeah.
we'll go back to the suspended call, and then since we were at 4, we were at traversal of t dot left, which is line number 3. So for 4
Correct.
we'll go to line number 4 now, which is
Yeah.
nothing there. So t dot right is like undefined. Not
Mm-hmm.
undefined. Okay,
I mean,
coming
it's
from
not going
Java
to that.
script. No, so saying undefined, it should be none. Yeah, for Python. So t dot right is basically nothing. So we just don't do anything there. We'll print 4 now.
Yeah. So it's 1, 3, 4. Go ahead.
All right. And then we'll come back to the suspended call for 2 again, which is from traversal of t dot right, because for 2 we were stopped there at line
Yes.
number 4 for 2. So we'll
Okay.
then
One
print
second.
2.
One second. One second.
Hmm.
Others, are you guys able to follow what is happening so far?
Yeah.
Mahi, are you able to understand?
So only
Or any
one
doubt?
doubt,
Yeah, please ask
because
them.
when we are going into the interior recursive call, when there is no right, like when t is not equal to none only, we are coming inside the if loop. So what will be
Correct.
written with none? Is it kind of none?
Nothing. Nothing. There's no return. It's directly come out of the function.
So yeah, so for t dot right, so assuming t dot right gives us a none, what happens is that the function call will be called, right? So the function
Yes.
traversal of t dot right will be called,
And
but
you
then
won't
it
come
will,
inside here.
yeah, it will check that t is none, because in that case it will be none, and then it will kind of just
Come
do
out of
nothing
the,
and come back
Come out of the function. Simple.
and then print. Okay.
and
Yeah.
then print. Yeah.
Mahi, did you understand this? Okay. Yeah, Mahi. Any doubt?
Yeah.
Tell me. Where is your doubt?
Actually, I miss it.
Okay. Okay. So, Afnan, why don't we give this question to Mahi so that she can try it?
Yeah, of course, sure,
Hope
sure.
you got it right. Yeah. Mahi, come on. Let's. So, how much did you understand?
No, actually, I was not there. Sorry.
Okay. So, but you can try this then.
Okay.
Mm-hmm. So, we are having traversal of 5. So, we are starting here, right? Okay. So, what are we doing at the line number 2, Mahi?
We are checking its t is not equals to none.
Yeah, 5 is not equal to none, right?
Yeah, 5 is not equals to none.
So, what do we do?
So we are going to traversal t dot left. Okay.
What is t dot left? It is t dot t of 2,
2.
right?
Yeah.
Mm-hmm.
And then
Now we are going inside. Now we are calling t of 2, right?
okay.
So
Then we
2
are
is not
creating
none.
a loop.
Yeah, t is
Yeah.
not none. So you go to the left of 2, correct?
Yeah.
Hmm.
Then it's 1. Okay.
T of 1, and this is
And
not none. So you go to the left of 1. Left of
yeah.
1 is what? Left of 1 is none. Right of 1 is none.
Yeah. Okay. So we are okay.
Printing the value,
Yeah.
right? So we are printing 1. Okay. Now the left part is explored, right? So after you explore the left part, you have to explore what? The right part.
Right. Yeah.
Okay. Do you have anything on the right of t of 2? Yes,
Yes, it's 4.
it's 4. Okay. And do we have any? So for now we are calling t of 4, right?
Yeah. And
Okay.
then
And
we are
we are
checking. Okay. We are checking.
t of 3. Do you have anything on the t of 3 or left and right? Do you have anything?
No.
No,
It's
we don't
none.
have anything on the left and right. It's none. So we print that.
Yeah.
Correct. Okay. So now we go up a little bit. So we explore the right of. I mean, now left of 4 is explored, right? So now we are going to explore the right of 4. So what is there in that? You don't have anything,
None.
right?
Yeah.
So you have explored the left. You have explored the right. Now you need to print
Explore
4.
4.
Yeah, when T and I mean left and right is done, you're exploring what? 4, right? I mean, it's not exploring. You're basically printing 4.
Yeah.
Then
And then
2.
and then
Good.
5.
Next,
5.
not 5. You still have right side, no, for the 5.
Okay.
Mahi?
So okay. Yeah.
Yeah. So for when you were exploring 5, I mean when you were trying to traverse the 5. So for the left hand side, you completely traversed, right? So now this line is done. So now you come to the 4th line, and you're going to traverse the right hand side of 5. Only
Yeah.
after right hand side of 5 is explored, I mean traversed, then only you will be printing the 5. Correct?
Yeah.
Go ahead. Go ahead.
Then 8.
Are you supposed to print 8?
No.
Yeah. T of 8. Go ahead.
And then we explore left part T6 and then T7. No,
Yeah. Then,
that's
yeah. We
right.
don't have anything on the left of T6. Then we go to the right of T6,
Right.
which is
Yeah.
T of 7. We don't have anything there. Then we print 7. Correct. Now this
And
is
then
traverse. Then
6,
tell me. Yeah.
6 8,
Mm-hmm. Good. So now 8.
and
No,
9.
not 8. I don't think we have
It's
8.
9 and 8.
T of 9. Okay. Which is 9. Then comes 8. Then
And then
comes 5. Okay. So this is the order. Others, were you guys able to understand? I think Uma was able to understand that. Huffman was done. Nomit, are you okay with that?
Yes.
Great. So we shall check whether we got the correct output. So 1, 3, 4, 2, 7, 6, 9, 8, 5. Yeah, we got the correct answer. So what? So yesterday we studied something, right? In order, pre-order, post-order.
Yeah, this is post-order, right?
Yeah. Okay. So what is in order?
Root left, right.
Correct. So in order is like sorted. We can simply say like that. Correct. It's in order. You can say like that. So this is post order. If it is pre-order means how will you do the pre-order? So first you explore the leftmost part, correct? I mean for pre-order it is left, parent, and then the right. Okay.
That's in order, right? Parent is in the middle.
Okay. I'm sorry. I think I got confused there. Then what is pre-order?
Pre-order is like parent, left, right, I guess.
Yeah.
Yeah. I forgot now. Okay. Yeah. Parent, left, and right. Yeah. Thanks for that. Yeah, I remember because in pre-order we have the parent at the starting itself, and in post-order we have the parent at the end.
Exactly. That's the best way to remember.
Mm-hmm. Oh, okay, that's nice. Okay, pre-order means we have the parent. I mean, the parent at the first. Thanks, Shrina. I think is it clear? Mahi, did you understand?
Yes.
No, whatever we were talking, pre-order, post-order, and insert in
Yeah.
order. So pre-order means we have what at first?
It's parent.
Sorry.
Parent should be at first.
Yeah, parent. The supermost parent should be at first. Yeah, that's correct. Fine. Okay. That question was good. I think how many questions do we have? We had only 14 questions. Fine. And this is done. So coming back here, who is going to do this? Nomit, I think you should do this. Right? We don't have anyone else here talking. Okay, Nomit,
Which of the
can you talk? Yeah, talk.
which of the following statement is true about the complexity of the given traversal function where n is the number of nodes?
Mm-hmm. Okay, I think this is related with the previous one. See, so they are saying
Hmm.
that 18, 17 and 18 you have the same. So they are asking for what? Complexity. Hmm.
Oh, so it will be ON.
Why ON?
Because it's going through each and every node. So it will
Okay.
be ON.
They're asking about balanced or unbalanced. So how do we tell if a tree is balanced or not? Nothing but the AVL tree, right?
That at most the difference of left subtree and right subtree is 1.
Mhm. So in order to find out whether a tree, yeah, Uma, tell.
This is binary search tree, right?
AVL tree, yeah, AVL binary search tree. You're right. AVL tree is a binary search tree also, right? Balanced binary search tree.
Okay.
Okay. Yeah, Nomit, you're okay with the complexity?
Yeah.
Okay. Can you mute yourself? Okay. So Mahi, can you tell me how the complexity was ON? Mahi?
N is 2
Mm-hmm.
nodes, whether the tree is balanced.
1 minute. So the question is, for the traversal, we are finding the time complexity. Is that so?
Given traversal function.
Complexity about of what?
Saying, nah,
Yeah,
whether
of
so
the
because
traversal function. Yeah.
For traversal, it's big of n because we have to traverse every node,
hmm,
whether it's balanced or unbalanced.
absolutely.
Yeah.
Mahi got it?
Yeah.
Hmm. Yes. Okay, so we come to the next question. Hey, wait a minute. Is this from what is this? Low, high, array, last index, match, mystery, suffix, prefix, subsequent, substring. Okay, substring question. Okay. So shall it? Okay, wait. Is there anything like okay 189 and 190? We use this. Who is left? Nikhil did it. Mahi did it. No, Nikhil did not do it. Afnan, would you like to take this again? I think is it coming in loop or should it Uma? Is it Uma's question? Whose question is this? Okay, Afnan, are you here?
Yeah. Would somebody else
Yeah,
like
yeah.
to take this one?
Somebody else want to do this? See, obviously we will have questions like this, and you see, this is like how many marks is there? 4 marks question. And it's okay. Like even I don't know the code. Okay, okay, wait. I'm gonna do it. If no one is gonna do it, Afnan, you want to do that?
No, you can go ahead. I think. Yeah. Okay. Sure.
No, let's just read the question. Let's just read the question. Okay. So
Yeah.
consider the following function. We have some function called as mystery, which is taking an array. I think ARR, low and high. Okay, where ARR is a list of strings. Okay, now it's a list of strings, and low and high are the first and last index of the list ARR. Simple. Okay, so low and high is going to be the fine. That's okay. So now we have something like this, and then we have something like this. Fine. So for example, if the string t equal to a b c d e f. Okay. So suffix of string s, suffix sorry, a string s is a suffix of string t. If there exists a string t such that t equal to ps. What is this? Okay, example, yeah, def and ef.
So see, suffix is whatever comes after.
Huh.
You know. So it is same, right?
After
EF.
certain number, right?
Why
It comes at
EF
the end.
in
Suffix.
DEF? Yeah,
Mhm.
in DEF, EF is a suffix because EF comes after at the end, right?
Correct.
That's a suffix. Yeah, at the end, in fact. Yeah,
Yeah.
because see, if it is in between, then it will be called a substring. If it is at
Mhm.
the beginning, then it will be called a prefix. If it is at the end, then it will be called a suffix. That is that.
I think okay. This is they're just
No, no,
giving us
substring is a little different, right?
substring should be continuous, not just in between. It can be in. I mean, the only thing is it should be continuous. That's all.
Yeah, in between and continuous is kind of assumed, no?
Yeah.
It can start at the yeah. You can write. It can start at the beginning also. Still, it's
Yeah,
a substring.
yeah,
But
yeah.
if
Because
it's
see,
starting at the beginning, then it will be suffix basically.
yes, exactly. Because see, I see both prefix and suffix as a substring also, but that they are special cases of substring.
Yeah.
For the prefix is a
Correct, correct.
substring and suffix also is a substring. But then
Yeah.
prefix, there is this condition that it should be at the beginning, whereas
Mhm.
suffix it should be at the end. That is what.
Okay.
So is that reasoning correct? I think it is
Yeah,
correct.
yeah, yeah,
Yeah. Okay.
yeah. Okay. Fine. So this is all happening. So we have some function which is match function and mystery function. Let's see. Let's see. So what does the mystery function return? See, it's a 4 mark. Just we need to understand what is this mystery function. Okay. Fine. Low and high. So we saw that low is going to be what? ARR is an array of characters. Huh? What was that ARR? It's a list of strings. Oh my god. Fine. Not a problem. Not a problem. Let's take this towards the right. I mean the diagram. Mhm. So let's take a few. Let's take a list of strings. What shall we take? Okay, string. Then one substring, one prefix. Okay, I'm going to take one suffix, right? And then I'm going to take one, subs. Then what is it? What was it? Substring, huh? Yeah, substring means what is substring? Sorry, Uma?
I thought subsequence, right? They have both.
Subsequence
Yes,
means
RI
what is
subsequence.
substring?
RI probably will be a substring.
Okay, Ri is a substring. Then subsequence means S or G, right?
Yeah.
Correct. Correct.
And we'll have some word like X, Y, Z, something which is not there. Okay, or let me say SXZ, XYZ. Got it? 4 character. Fine. So if now come on, who like okay? So what is low going to be? Low is going to be the starting index of the list. So it is 0, right? And high is going to be the ending index 0, 1, 2, 3, 4, 5, right? Okay. So if for example, if it was just only one word, the starting and ending is equal, and we are returning year of low, and it is returning the whatever is it is supposed to return. I mean, only one is there, and we are returning it directly. Okay. So if high is greater than low, obviously that's the other case, right? So we have phi here. If phi is greater than 0, okay. So we are finding the middle of this. So it's going to be what? I think it's going to be 2, right, Afnan?
Yeah, but because it will be divided, but then it will get 2.5. But since you are using a double slash here, it will
Yeah.
be 2 only.
Exactly. So phi double bar 2 is going to be like 2, and then we say that mid is going to be the 2. 2 is numerical, mid equal to 2 numerical number of the string. Okay. So now what are we doing? We are doing a recursive call. Str1 equal to mystery array low mid. Okay. So I think we are calling. I mean, so low mid. Okay.
We're calling the left side of the array. We're doing the same thing for the left side of the array, right?
Yeah. Do we include the mid or not? That's the question here.
Yeah.
Okay, we include the mid.
Yeah,
Okay.
we are putting high in
Yeah,
mid.
yeah, we include the mid.
So we include the mid, and then string 2 is going to be this. Okay, we have str1 on the left, and we have
So we're
two
trying
on
to
the
match
right.
the mid of, yeah.
Yeah. Now we are calling the match whatever the left part and the right part. Okay. See, we are just exploring code. Even I don't know what is going to happen. So now there is something called as match function. I thought like only one thing was going to happen. Fine. Okay. So
No,
we
no,
got
first, what is string 1 and what is string 2?
string 1 is basically the left part of the array.
No, no, I think they're calling it again, no? So want
No,
it,
no, 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 no. Calling the mystery. It's calling the mystery again. I'm sorry. I'm sorry. I'm sorry.
yeah, yeah,
Yeah,
exactly.
the call
Until
for
you
this.
get one element in the
Yes,
array,
correct.
yeah,
Correct.
until you are left with one element in the array, you keep doing this.
So initially we had like 6, right? So and then it got split into 3 and 3, right? So this is now this is gonna get split. So 3 double bar 2 is going to
One
be
and
what?
two, right?
One
Yeah,
and two.
1
One
on
and
the left and 2 on the
One and
right. Correct?
yeah,
Yeah, and then this is gonna happen. 1 on the left and 1 on the left. Am I right? This is how it's gonna happen, right? Srinay?
right, correct.
Yeah. So
So just a question here, excuse me.
yeah. Hmm.
So in this three, we are assuming that that will be that is high, no? That represents high for that particular
Yeah.
Correct,
at
correct.
that particular level. So
Yes, yes.
that is high, and then what we are doing is we are summing low and high. So low, I believe it will be zero still at that point.
Yeah.
Yeah. So it will be 0 plus 3, it will be 3. And then we divide by 2, so we'll get 1.5. And that will get assigned to mid. I mean, 1 only.
Yeah. Yeah.
That will be mid. So for the next call, mid is okay. The next call, mid is high. So I think it should not be 1, 2. Rather, it should be 2, 1 is what I believe. I mean, if you are going by the order.
No,
Uh,
array, comma, low, comma, mid. Mid is 1. Low is also 1. Low is 0, right? So array, comma, 0, comma, 1.
okay.
You you said that mid will be equal to low plus high divided by flow divided by 2. So that will give us 1.
Correct. Correct.
Yeah. So 0, comma, 1, right?
0, comma. Because low is not changing at all, is what I can
Yeah.
see.
Yeah. Yeah.
Okay. Correct. Correct. Okay. Thank you.
Wait a minute. Isn't it like
So the
two and
second
one?
time, sorry, what?
Isn't it 2 and 1?
No, no. Again, Gokul. So when you're at 3, right?
Yeah,
3 is
wait
the
one second.
high.
No, no, three is not the. I mean, so let's
No, when
come
you
to
are
this
inside
one.
those first three elements, right?
Correct.
Your low is 0, your high is 3.
Not three. It is two.
2.
I. Huh.
2 plus 0
It is.
by 1, by 2, right? That's 1.
That's one. So which means mid is going to be one now.
Yeah.
Correct. So
Oh, okay.
got the point.
0, comma 1. Okay, okay. Makes sense. Sorry.
Yeah. Afan,
Sorry
thanks
about
for
that.
that.
Yeah, fine. You're right. You're right. I think two elements will come on the left and then one will come on the right because we are indexing it. We're not telling the number of elements. Yeah. I forgot the
Yeah.
zero index.
Yeah, yeah, that is why. So, assuming that the left part represents the low and the right part represents high, so then it'd be 2, 1, 1, and then the right part is 1.
Yeah.
Yeah,
Yeah.
correct.
Okay. Yeah.
Mhm.
Correct.
Okay. So now why I did it basically like we can say that so this is the first one, second one, then we are going to match it. Then after this is matched, so then we
Correct.
can match. That's why I drew a graph like this. It can be easy for us to visualize. Now we are calling the match function for the first and second word, right? So strang and str. Okay. So we are passing this. Okay. So what is the match function going to do? Afnan, please go ahead. We
Okay.
have result.
Shall I
Yeah.
take this? Okay,
Yeah.
sure.
Please.
So, in the match function, we are accepting two strings, which is str1, str2,
Mhm.
and then initializing a result string. And this is similar to, I can say that this is similar, kind of similar. I mean, like at first glance, it seems as if it is similar to merge function that we have in the merge sort thing, but of course, unrelated. But it seems similar. Okay. So
It's
n1
not.
and n2, we have the lengths of both the strings respectively,
So
and
which
I
is
comma
in
j
this
we are
case,
initializing at 0,
this
0.
case 6 and 3, right? In this case 6 and 3.
Should be,
We are passing
should be
string and str. Go ahead.
correct. Ij is initialized to 0, and then
Mhm.
we are initializing a loop while I less than n1 and j less than n2. Essentially means we are kind of looping over everything, right? That is what it means. Because
No. So this while loop is gonna run only for like three
oh,
iterations.
all right, okay. Whichever is minimum, I think that will,
Ah,
because this is an and, that is why, no.
correct.
Had it been an or, then it would have been like continuing. But then since it's an and, if one of the
Mhm.
condition is finished,
Very-
then yeah, correct,
very
correct.
easy topic. Come on, go ahead.
So if str of y not is equal to, so at any point in time, if we get something which is not matching character by character, if it is not
Mhm.
matching, if we get one character which is not matching, we immediately break out of the loop.
Correct. In this case, it's matching, right? So first character is matching.
Matching. Okay, so we'll continue, right?
Yeah.
Both the counters, sorry, both the pointers will kind of increase by one.
Increase and see result also is being increased. STR, right?
Yeah. So that thing which is matching will take into account. So that will be
Correct.
get added to that, appended to that string that we have
Yes.
kept that result.
Mm-hmm.
So we have, I think we do not have str, no? We'll just have s at one, in one iteration. We'll just have s, no?
Yeah. Yeah. One iteration we just have yes. You're right.
Yeah.
Okay.
When we go
The
on
second
to the
iteration,
second, uh, we'll have t.
correct.
Again, we'll have r.
Mm-hmm.
At this point, I think I and j both are 3.
No, third iteration, I and J are three. Correct.
Correct.
And the fourth iteration, yeah. So I
So
as I, and we don't have anything like that's all. Like we can't, right? We can't go further. I mean,
we can't
see,
go further. So while loop, we are
it won't
exiting
even
the
be three. It won't even be three, right? It stops at two itself.
we are starting from 0, no? Yeah, correct.
Okay, so we are just returning this result str.
STR.
Okay, seems like the match function is returning the prefix. I think.
Because we are starting at 0, it seems it is going as long as it is matching. It is continuing. As soon as we found non-matching character, we'll exit.
Correct.
So going by the code, it seems that right. It is prefix only.
Yeah. So we
One
got.
second. Is it only me, or if I feel like this will the line number 6 will throw an error at the
No, it won't. It won't. Where are you? Why do you feel like that?
because okay. So N1, let's say N2 is 0 first. So we're looking at S of
How
sorry
come N2 be
string.
0? N2 cannot be 0.
No. For in the first iteration, N2 is 0, right? So we're looking at string 1 of 0, string 2 of 0.
Bro,
So you're
J.
looking at S.
Are you saying? Are you talking about J or N2? Which one you're talking about?
So N2 is value 0 at the first iteration, right?
No,
At the first iteration.
bro. N2 is you're talking about J. I think.
Sorry. J. Sorry. J is 0.
Yeah.
Yeah. 1 second. 0, 1, 2. Okay, yeah, understood. Okay, I thought it was N2 less. Okay. I thought N2 greater than J. Okay.
Mm-hmm. I hope that is clear. So
Yeah.
I think I think it's fine. Any other people having any doubt here until this point? Anyone we can discuss. Uma, Mahi, Uncle?
Clear, yeah.
Yeah, nice.
Because
Okay.
it will not
So
be matching with any of the matching function, no? This function will not run at all for any of the other function.
correct. If the characters are not matching, yeah,
So the
right.
first character itself doesn't match.
If the first character itself is wrong, yeah, it will stop.
Yeah. So
Perfectly understand. Okay, so let's see what is going to happen for this array list. Okay, so str. So it's going to return str for the left, right? On the right hand side we have ng. So it is not matching, right? Str and ng is not matching. So it returns an empty list. Correct.
yeah.
So here also it's going to be like, so let's see. So ri. So this is not matching. It's giving an empty list. So if you by the time if you have an empty list, then obviously like empty string. I'm sorry for that. So if you have an empty string, the corresponding thing also will be empty. Like all will be empty, right? Hello.
Yeah.
Okay. So when will this actually return something? Really, Okay. What does this look like? When will this actually return something? Uma, can you suggest? Can you tell? Any idea? So to actually get some value out of this, I know. Okay.
Because
Anyone else want to try? Yeah, tell Uma.
in any one of the, but for that we have to repeatedly have the thing, right? The prefix.
Correct. Yes, exactly.
STR, at least ST. If you have STS, then we might finally get a S or something like that.
Correct.
Otherwise, like you,
So
yeah.
str. Right now we have four. Right. So this gets split. Right. So this is split into string and string. So if we do this, then we'll get strin. Right.
So
On the left
in
hand side,
that case,
strin. Yeah, Uma.
but here at least one prefix we are having. Still, we are not able to get it right.
What do you mean? So this will return us. I mean, what I can clearly say is that it's going to give us the prefix of all the letters here. If you have a matching prefix.
Okay, no, but we have one, right? The second one is STR. Still, we won't get a result,
What
right?
do you mean by second one is str here, right? At this point, huh?
Yeah.
Yeah, we are not going to get anything. You're right.
So even though we have, we will not get anything.
Yes. So only when you have all the when all the substrings, like when all the elements strings have a common prefix, only that will be given.
Okay. Yeah, got it.
Yep. Mahi, understood? Mahi?
Yes. Yes.
Okay. Any doubt here? Do you feel some word anywhere? Are you confident here, Mahi?
Yeah.
Okay. So okay, I think it's okay, right? Okay, right? Like I think it's fine. So we saw what was match and mystery, and see, so longest common prefix of all the strings in the list array. Correct, Afnan?
Yes, it is correct.
Exactly. Oma also got it, I think, right? Everyone is fine.
Yeah, yeah, got it.
Okay, great. So now that we have explored this, this is the last question. We'll finish this up. We are finally finishing this. Nice. Okay. So which of the following are true about the mystery function? Assume the size of the input list is n and length of the longest string in the list is m. Okay, we have some longest string which is of size m. Fine. Uma, would you like to try this? Let's
Yeah.
just try. Finish it up first.
So function mystery, first choice is function mystery is an example of a greedy algorithm. Is that so?
Okay.
I will connect with the greedy algorithm.
Now, how do we connect this with the greedy algorithm? Srivanay, can you help us here?
This is the one we have to choose.
Yeah. Okay. I can connect it like this. So I remember saying that in greedy, okay. So what you do is, so let's say like you have to do perform to 1, 2, 3. Okay, like wait. So 1, hmm, 2, 3, 4, 5, 6, 7. Okay. So in greedy algorithm, you just go towards one step, right? You don't actually come back to what you did. Am I right, Uma?
Yeah, yeah. No, I'm just connecting with your previous example list. So it is like string, str, sts. Even then, we can't get it right. According to
Uh,
the code, this might be returning the strings, right?
yeah. So
No,
this is okay.
string
What?
str.
Okay, wait a minute. So the other one, the first one which I wrote,
No, not the
right?
one. No, that won't anyway come, right? This one, whatever written is, we will reduce one letter so that
Mm-hmm. So if you reduce one letter, tell
is
me.
the algorithm kind of, right? Am I correct?
Correct. Correct. This will return us some value. You're right.
Yeah, but that is not the case, right?
Hmm. Hmm. So you have the previous question, or you are trying to answer this question?
This question is, I'm just thinking, what is it saying? Greedy algorithms.
Ah, greedy algorithm means so it's like you don't come back.
Okay.
Okay. So in this case, it's a divide and conquer algorithm, right? So you divide the, I mean, whatever you're supposed to do, you divide it.
Yeah.
Like, see, you're trying to find out the common prefix of all the things, right? So you're trying to first find the prefix of 2, then the 3, then the 4, the right hand side 4, then you sum it up.
Yeah.
Okay. So basically, you're actually using the previously computed values. I mean, you're looking back,
Yeah. Okay.
right? So hence it's not a greedy algorithm.
Okay. For time complexity, can we go up?
Yeah, time travel complexity, we can discuss that. Hmm. So what could be the time complexity?
It is like log n, right? It was like
Um,
merge sort, right? Is it not?
yeah, it's exactly like somewhat like merge sort, but still we'll discuss about the complexity.
We are dividing into half, so it should be almost similar to we are completely dividing into half, then merging, with comparing.
Correct. So dividing into half, like so I
Yeah.
think like so this mystery function is gonna take how much? So this is log n, right?
Yeah.
Dividing it.
Yeah.
Okay. So on comparing it,
N log n. Right?
no, it's not n. It's going to be the minimum. But for merging it, so you remember we are doing something like this. Complexity of the function mystery of n. I'm not sure. Okay, are you saying that
So
it is?
you cannot. So just to add, Google.
Yeah, yeah.
So we cannot assume anything about the size. No, theoretically speaking, right? Because it may happen that everything matches, right? That will be the worst case thing because it has to go through everything.
Okay.
I mean, in
Everything.
this case, in this case, what happened is that we got STR and we kind of stopped there. We didn't go, ahead.
Correct.
But it
Yeah.
might happen that we might go ahead also, right?
Mm-hmm.
So we'll have to talk about the worst case thing. Then I think it will be an O of n because we are anyway looping over everything, right?
Yeah. Okay. So this is going to be n. So let's come back here. What is n and what is m? So m is the longest string in the list, right? So this iteration is going to go for like m, right?
At most, yeah, yeah.
Yeah.
O
At
of m.
most
Yeah.
m
O
steps.
of yeah, O of n.
Mm.
Mm-hmm. Big O of m, right? And this is going to be log n. So and this is going to be like m log n. Am I right?
Yeah, yeah.
And they
O of
given it
m
like
log n.
n. Yeah. So
So
is
for
that
each
clear?
of these log n, sorry. So for each of these log n levels that we have, like in this divide and
Yeah.
conquer strategy, we are
Yes.
doing m steps of work basically, right? O of m thing. So for each of these levels, we are doing that, so that gets multiplied. So we get m log n, right? That is
Yeah. M
every
Yeah,
steps to merge. M steps to merge.
merge. Yeah, correct, correct.
Gokul,
Okay.
I'm
Right.
not getting the order of yum. How do you say
Yeah.
order?
So the longest string in the list is m. Correct.
Yeah.
And just like Afnan told, what could be the worst case? All the strings are the same.
Okay, okay. Because I was thinking the J is, whichever example we took, it is smaller, so the iteration
Correct.
went only up to that. Okay. If
Yes.
it is all or M. Okay.
If all are m, that is going to be big O of m,
Yeah.
right? And you know how it works further.
Yeah. M into log. Yeah, yeah.
I need to log in. Hence the answer. And finally, we have successfully completed this first one paper, and we completely completed. Good. Fine. So there was a lot of time. So now let's discuss. Not now. Tomorrow. Okay. We'll discuss one of these. All
wait.
right, Kumar.
Did the last option say that the complexity is n into m?
Uh, wait a minute. What is this? Oh, I did not see this. Oh my god. Yeah, I did not see that. I'm so sorry. Damn.
Okay, even I'm confused now. Sorry.
It's okay. Complexity for the mystery function. So it's talking about mystery function, but still it's the mystery function always. Hmm. Oh my god. Hmm. So okay. Uh, okay. Why don't we discuss this tomorrow? Like, Shivan, can you ask it to the other people?
Yeah. Can someone post it? Like, so yeah, maybe even I'm confused. I thought it should be m log n as we discussed, but maybe we are missing something here. So maybe you can, yeah,
Probably. See, the thing is sometimes the questions, the answers here are wrong.
yeah, maybe, yeah. I mean, it would have come on Discourse already if that was the case. But yeah,
Mhm.
let's see.
Okay, so I have sent it there in the chat. So Shivan, just for you to have a reference later.
Sure, sure.
Okay. So tomorrow you can answer this, right? Now it's not the
Yeah,
time. So.
yeah. I'll try to answer.
Okay, is it fine for all, guys?
Did I send the answer for the sorry, the heap question?
No, I don't think
I
so.
got the explanation for it. I'm sorry if I didn't put it. Maybe I'll put it on the Google chat and the
You want to say that answer? Like, how long will it take for you to do that?
if you can write it. No, let's do it tomorrow. I think it's already late today.
Already late, yeah,
Um,
9.
oh, tomorrow I think you're not coming, is it?
No, I'm coming.
So
See,
tomorrow is
so
the
tomorrow
last.
will be the
Okay,
last session. Yeah, tomorrow will be the last division session.
okay, fine. Tomorrow I'll get to